In this video, we're going to find uh, some of the values in the arc length formula. Knowing two of the values, we're going to find the third. So the formula is R is equal to S, is S is equal to R theta, where S is arc length, R is the radius, and theta is the central angle measured in radians. We can solve that for R if we need to. R is equal to S over theta, or we can solve it for theta, where theta is equal to S over R. So we're going to need all three versions of that. Most of the time we're going to be solving for S, but remember that this angle here needs to be in radians for this formula to work. So let's go ahead and do that in our calculator. Remember that S and R are going to be in the same units. So if I take 17.29 times 5.8, since it's already in radians, there, that my S is going to be, and we're going to round this to the nearest tenth of a centimeter here, that my S is approximately 100.3 centimeters. Now, before we can calculate our arc length in number 2, we need to change 315 degrees into radians. So we talked about how to do that in a previous video. I'm going to multiply by pi over 180. So let's just divide by 180 here. That is 5/4, I believe. 7/4, excuse me. So theta is 7 pi over 4. There we go. And so I'm going to multiply now 11.7 times 7 pi over 4 radians. And I'm going to say that S is approximately 64.3 inches. Now I have R and S and want to calculate theta, so I'm using the third version of the formula over here. S divided by R, so 24 divided by 3 divided by 5 goes in parentheses. That's going to give me 40 radians. I don't have to put radians as the unit, but I will, just to make it clear that I measure that it's an angle measurement, but radians are unitless. And S and theta, we're going to calculate R, so we're using that middle version there. So 3.3 divided by 1.1, and R is going to be in the same units as S, so this is going to be 3 meters. We can do the same thing when they draw a picture for us like this. We identify that we have R is equal to 9 yards and theta is equal to pi over 3. So we're going to have S equal to R theta, and that's going to be exactly 9 times pi over 3 is 3 pi yards, but we're going to approximate that to 1 decimal point of precision, and we're going to get 9.4 yards. We have our R is 7 yards here, and our theta is pi over 5 radians. So S is equal to R theta. It's going to be 7 pi over 5 yards. Let's approximate that. 7 pi over 5 is about 4.4 yards. Now they give us our angle in degrees, so we need to watch out for that. So R is equal to 11 yards. Our theta, they said, is 50 degrees, but we need to change that to radians. So let's multiply by 180 in the bottom and pi in the top. Degrees will cancel. Both are divisible by 10. This is going to be 5 pi over 18. So S is equal to 11 times 5 pi over 18. And that's going to be about 9.6 yards. R is 7 centimeters. Theta is 30 degrees. We calculated this one earlier in one of the earlier videos, but let's go ahead and do it again here. 180 degrees is in the bottom, pi is in the top, degrees cancel, and 30 goes into 180 exactly 6 times. This is pi over 6. That's going to be an important angle to us later in trigonometry, so remember that one. S is going to be equal to R times theta, 7 pi over 6, 7 pi over 6. This was in centimeters, so this is about 3.7 centimeters. Let's look at these word problems here now. There we go. So for a circle with a radius of 4 feet and an arc length S that we want to find that's subtended by a central angle theta of 30 degrees, which we just found out was pi over 6 radians. Round to the nearest hundredth to find the arc length. So 4 times pi over 6 is going to give us an arc length that is 2.09 feet. If the circle is 4 feet in radius and the arc length is unknown and the angle that subtends the arc length subtends a central angle of 60 degrees. We figured that one out earlier was pi over 3. And we're going to round to the nearest hundredth here. So this is pi over 3. And S is about 4.19 feet because our units of radius match our unit of arc length. Okay, now we have the minute hand of the clock. The big hand is 7 inches long, so that's my radius. How far does the tip of the hand move? That would be S in 45 minutes. So we know that the whole hour is 60 minutes, and we're going to go 45 minutes. So that's 4/3 of the circle. To show you that that's, I'm sorry, I should have gone the other way. It's 3/4 of the circle. We do that the right way. 45 minutes out of 60 minutes is 75%, or 3/4. So 3/4 of a circle is 2 pi. 2 goes into 4 2 times. So this is 3 pi over 2 for my angle. And then we're going to multiply here 7 times 3 pi over 2. And S is about this is round to 2 decimal places, 32.99 inches is about how far it goes. And a pendulum swings through an angle of 30 degrees each second. If the pendulum is 45 inches long, how far does the tip move each second? So we've got the pendulum is swinging 30 degrees like this in 1 second. So, and the pendulum is 45 inches long. So R is equal to 45 inches. Theta is equal to 30 degrees, which is pi over 6 radians. S is equal to 45 times pi over 6. And we're going to round this to 2 decimal places. So this is about 23.56 inches. All right, that's it for this video. We'll come back next time and we will talk about something else. See you next time.